2020 was organized at national level. Then we started for 2021, which was planned, organized at international level. Now, seeing the success of this event in last two versions, this time around also the event has been organized at an international level. It's my privilege to introduce our distinguished dignitaries and guests with the permission of our worthy Administrator Sahab Chaudhry Zakir Hussain Sahab and Chief Executive Officer Janab Muhammad Shaheen Sahab. In the morning session of yesterday, that is day one, we have our chief guest, Professor Dinesh Kumar, then Chief Patron Chaudhry Zakir Hussain Sahab, and Muhammad Shaheen Sahab, IAS, which was patron of this event. On day one, we have our two keynote speakers, Professor Dr. Muhammad Rizwan from DTU, and the second keynote speaker was Dr. Hasmat Malik from UTM Malaysia. Then in this particular day, that is the second day, we have three keynote speakers for this day. Professor Naqi Anwar Sahab from Rtreaet University will be our first keynote speaker. Then we have Professor M. Nijamuddin from the Jamia Millia Islamia, and after that we have Professor Rizwan Khan from AMU. So, with the permission of Director Sir, we are here for the second day, and I request Director Sir to welcome our dignitaries for the day. Director Sir. Director Sir, are you? Director Sir, are you there? Director Sir has always played very instrumental role in planning these type of activities. Whenever we approach to Director Sir for the help of organizing of these events, he is always there. And he doesn't take any time from our side to approve any project. So whatever project we go for the conferences or for other this type of activities, he's always there to sign the proposal, and after that these are sent to the requisite authorities. So thank you, Director Sir, for providing all the support, all the guidance which is required for organizing these type of activities. Sir, it will be great if you can say a few words. Director Sir.
Director Sir will be connected soon, sir. Just a minute. Just a minute, please.
Okay. Okay, then in the meantime, I can introduce our first keynote speaker.
Okay, okay, sir.
Professor Naqi Anwar Sir is professor in the Department of Sustainable Engineering at Rtreaet School of Advanced Studies. Earlier, it used to be Rtreaet University, New Delhi, and is a program coordinator of MTech Renewable Energy Engineering and Management. Professor Naqi has a very wide experience of teaching BTech and MTech students. He has acquired his BTech from Aligarh Muslim University, Aligarh, MTech from UP Technical University, Lucknow, and PhD from Jamia Millia Islamia, New Delhi. His research areas include power electronics, power systems, and smart grid. His current academic and research activities includes renewable energy grid integration. During his professional career, he is an admirable teacher and he held various administrative posts and remains instrumental in designing and development of academic materials and establishing new laboratories. He has one patent to his credit and more than 40 research papers have been published in international national journals and conferences. He has delivered a lot of expert lectures on renewable energy and related fields. He authored a book titled Electrical Automation, PLCs and SCADA. He has wide exposure in organizing national level seminars and conferences. He is a member of many reputed societies. Dr. Naki Anwar has guided 2 PhD scholars and 8 PhD scholars are pursuing their research work under his able guidance. So this is a bit about Professor Naki Anwar, sir. Director,
Very good morning. Yeah,
available.
very good morning, Dr. Shaheen. I think directly we can request Dr. Mecw to start his presentation. I formally welcome and known him. I find him a great teacher. He is a teacher by birth. And I have personally learned from him many electrical concepts. He's a very, very good teacher. I would love if he would be visiting sometime our college physically. That would be great for our student and faculty members. So we welcome Dr. Naki. Please continue with your lecture. Thank you very much.
Thank you very much for a nice introduction and very good words. So should I start now? Am I audible?
Yes,
sir.
you are audible. Please continue.
So
Yes, sir.
should I start now?
Yes, sir.
Okay. So without going into much deliberations now, let me share my presentation. My presentation is visible. Someone please confirm.
Yes, sir. Yes, sir.
So thank you very much and a formal good morning to all the participants of this wonderful conference. Conferences are always good because it brings many opportunities to bring many expertise on a common platform. So the topic for my presentation is energy conservation and sustainable development. As a brief introduction to this particular topic, I'm sure that every one of us know about energy conservation and keeping energy remain with us for future generations. That is the basic concept of sustainable development, that whatever resources we are using, we must use it in such a way so that we can left most of them for the future generations. So energy conservation leading to sustainable development is what we need to practice. As the name indicates, energy conservation is basically a way to conserve the energy. But there are many more aspects of energy conservation that we need to practically understand. Now, just for an example, that suppose with an objective to save some rice or some wheat, suppose we keep fast, but at the end of the day, we end up with consuming, say, some fruits or vegetables and not in lieu of the rice. So this is the way our energy conservation activities nowadays, that in order to conserve something, we are somehow emitting more CO2 into the atmosphere by those particular activities, which is ultimately appearing to be leading to energy conservation activities. Energy conservation means using less of energy. That's all. But what we are doing in lieu of that, so the levelized cost of energy or a life cycle cost analysis of those processes actually needed to be understood. With these words, let me start with energy conservation. So when we talk about energy conservation, it is basically our effort to reduce the consumption of energy by using less of an energy service. That is energy conservation. Means if you are using your bulb for 10 hours, if you can somehow use it for 8 hours, it becomes the basic of energy conservation. But energy conservation is not only about using less of energy services, but it is much more than that. Like energy conservation is finally our decision and the practice to use less of energy. It means energy conservation is not only limited to technical upgradation of what we are actually using in our daily life, but also is related to the change in use pattern of the services. So energy conservation ultimately should reduce the need of our energy service. And that must result in increased environmental equality, national security, and the financial benefits to the person using it. So as a whole, energy conservation is basically leading to preventing the future resource depletion, because obviously it will reduce our energy consumption. And always remember that energy conservation is important because 1 unit of energy conserved or saved is more than a energy generated because of the losses involved during the generation process. So more generation is no doubt one of our target, but at the same time, improving installed capacity and energy conservation has to go side by side. There are 2 objectives of energy conservation. The first objective and prime objective of energy conservation is to reduce the wastage and losses by technological upgrades of the existing equipments, which must result in improved O&M services. But another objective of energy conservation is to use energy more efficiently. That is to reduce the amount of energy used to carry out the same service. So there are 2 objectives of energy conservation. One is to improve energy efficiency by technological upgrades, but at the same time to reduce our use. Now, energy conservation always refers to reducing energy through using less of an energy service. But energy conservation and energy efficiency are 2 different things, although these 2 combined together lead to energy reduction techniques. For example, driving less is an example of energy conservation, but driving the same amount or the same distance with a higher mileage vehicle is an example of energy efficiency. So energy conservation not only reduces the energy services, but also it can increase the financial capital, the environmental quality, the national security, and of course the personal financial security, because it incorporates both the features of reduction in wastage and improving energy use. Now, if I directly give you an idea about the typical household energy use, we will find that our HVAC system, that is heating, ventilation, and air conditioning system, accounts for maximum load consumption. In our climate, that is hot and humid climate, it is largely we need the cooling throughout the year. And in the European countries or the colder countries, what we need is heating. But apart from that, and see, if I believe to IEA reports, International Energy Agency reports, this heating and cooling load in the days to come is going to be around 60% of the total energy consumption in a building, household building or residential building. Apart from that, appliances, lighting, and electronic equipments also are very, very prominently being used. So what is the objective of sharing this particular wagon wheel with you is to understand that there are opportunities where we can save very much of energy, but there are other equipments also which we can target in our daily life, because ultimately the energy conservation activities or the energy conservation opportunities in different appliances can be classified according to where we want to do it. So according to that, there are 7 categories of equipments: HVAC systems, motor inventory load, office equipments, kitchen equipments, thermal systems, mechanical systems, and lighting equipments. Now, out of these 7 categories, everyone can be changing their behavior, their use of pattern in order to conserve some energy. But what is necessarily, we need to understand that every equipment and finding energy conservation opportunities in every equipment is not every cup of tea. What happens that we need to identify some low-hanging fruits where energy conservation opportunities can be understood and can be taken up by everyone. And there are high-hanging fruits. High-hanging fruits are those fruits where energy conservation opportunities are many high, that is a lot of energy can be conserved, but everybody cannot do it. Like say air conditioning system, everybody cannot think of changing HVAC system in order to conserve energy. Similarly, our motor inventory and loads, similarly our process heating systems or our pneumatic and hydraulic systems, everybody cannot do it. So we classify the equipments into 2 categories: the low-hanging fruits, where the energy conservation opportunities can be incorporated by anyone, and high-hanging fruits, these 4: HVAC system, motor inventory load, thermal systems, and mechanical systems, where energy conservation opportunities are more but required skilled personnel. So lighting equipment, kitchen equipment, and office equipments. Lighting equipments, all our lamp loads, lighting fixtures come under this category. Kitchen equipments, those which we are using in our kitchen, that is for cooking purpose or for daily heating purpose. Office equipments nowadays are very, very important, and energy conservation opportunities can be looked at prominently. Office equipments like our laptops, printers, computers, mobile phones, all these comes under the category of electronic equipments, more specifically the office equipments. But what needs to be understood here, that energy conservation opportunities can be classified into 3 categories: low cost, high return, medium cost, medium return, and high cost, high return. As a normal consumer of electricity and as a normal middle class consumer, low cost, high return is always our priority. Rest all, that is medium cost, medium return, or high cost, high return activities can be prioritized, but there has to be analysis and engineering and budget provided for that. That is why in all our exercises, always the low cost, high return gets the priority. And practically, when we look into, this is theoretically what are the 3 categories, but practically when we look, the energy conservation opportunities are converted into 3 major activities, that is no cost, low cost, and high cost, as far as from the investment perspective is concerned. So what happens that if we prioritize our energy conservation measures, then what we will be looking at, that my priorities, my activities must be economically feasible, technically feasible, and there should be a less of uncertainty and risk associated with it. So those energy conservation measures where the economic viability of the efforts can be well defined and can be attractively placed using the same existing technology with no risk, that receives a highest priority and classified as class A measures. Class B measures, again, the economic viability we need to define very well, and we need to see that at least those must be marginally acceptable. And These using the existing technology with some upgradation. So the moment we are technologically upgrading it, the existing technology, some kind of risk and uncertainty will be associated with it. And these are classified as class B measures. Those measures where the economic viability is not clearly defined, or it is marginally acceptable, but a change in existing technology is needed, that is something to be replaced completely, then your risk becomes very, very high. And that is why it goes to the class C energy conservation measures, which is not getting any priority. And those activities where we are not very sure about its economic viability, and also complete replacement of a system is needed with an enhanced risk, those activities clearly is a no, comes under the class D energy conservation measures. So as a summary, what we can say that those energy conservation measures where economic viability can be prominently placed using the existing technology, and there are low risk or no risk, that kind of energy conservation measures will get on priority. So based on these three concepts of economic viability, technical feasibility, and lowering the risk assessment, the typical energy conservation measures for different equipments can be divided into no cost measure, low cost measures, and high cost measures. No cost measures are always related to our behavioral change. That is change in our use pattern, change in the pattern of the equipment use. Low cost measures are like technical upgradation of the existing technology. And high cost measures are replacing the existing with completely new system. Like in the lighting fixtures, switching of the lights in unoccupied areas or where natural daylight can be used comes under the category of no cost measure. You are leaving the room, switch off all the lights, that comes under the no cost measure. So no cost measure are the behavioral change. Everyone and anyone can do that. Low cost measure where the investment is less because we are using same kind of technology which was already in use, like say replacing our incandescent lamps with the CFL or the LEDs is an example. And whenever flood lamps is required, we can go for halogen or neon based lamps. High cost measure is upgrading the existing system completely. Like say we are replacing or we are including automatic controls in our lighting system. We are using sensors to control the lighting on and off process. So microprocessor based lighting controls. So that requires high cost measure because complete replacement of the existing technology is needed. Similarly, in the heating system. So if you are using multiple heaters in multiple rooms, individually smaller, instead of that, a centralized heating system can be used. So no cost measure is like at what temperature we are using it. So behavioral change, that is the no cost measure, that instead of using it at say 30 degree or 40 degree or 30 degree centigrade, what we can do is we can use it at an optimum temperature. Low cost measure is simply providing say thermostat based heating. So after some time it will automatically turn off. High cost measure is like you use the on-peak convectors or fossil fuel based heating equipment. So that comes under the category of high cost measure. Similarly, HVAC systems. So behavioral change, that instead of setting my AC on 23 or 24 degrees centigrade, if I can make some compromise and change the temperature to say 28 degrees centigrade or 29 degrees centigrade, that requires less of energy. So it means no cost measure is directly related to our behavioral change. Low cost measure is like we are providing some kind of automation into the HVAC systems and using variable speed drives or variable refrigerant drives. High cost measure is like we are using a larger system where a huge investment is required and ducts are being provided like the cassette AC systems or the centralized AC systems, and also to use like heat recovery systems. And so that requires high cost. In the longer run, that may give you more benefit, but at the initial, it requires a heavy investment. Similarly, motor drives, no cost measure is using the motors only when we need it. Like say your requirement is your water tank is say 1000 liters, but you know that according to your occupancy, you know that you require only 600 liters. So not to fill it completely, just use it when you need it. So that is a behavioral change. Similarly, low cost measure is like you are fitting some kind of automation into the motor in order to automate its operation. And high cost measure is replacing the existing motor with a higher initial investment requiring device, like say a solar water pumping solution, or say replacing the existing motor with a BLDC motor or so. Similarly, for the catering equipment, that is kitchen equipment. So avoid using cookers for space heating or switch on only when necessary. These are some of the no cost measures which requires just behavioral change. Similarly, looking at wear and tear and replacing all those equipments, all those parts which are under wear and tear with the good quality equipment comes under the category of low cost measure. But if we want to switch completely to say electric cooking system in terms of induction or say induction based heating or heater based heating systems, so in that particular case, what happens, a huge investment is required, and that comes under the category of high cost measures. Similarly, for the office equipments, behavioral change, that is, if you are not using your laptops, if do not put in sleep mode, switch it off. Similarly, I have seen practically many a number of times when we manage to shut down our CPUs, but do not take care that we need to switch off our monitor as well, because our monitor went to sleep mode. But even in sleep mode, it used to consume some power. So a behavioral change comes under the category of no cost measure. Low cost measure is like you can fit some time control, like during your say office equipment, say your coffee machines or your tea machines, you can fit timer into this one, that for some time it will remain on when it is being used, otherwise it will remain completely shut down. Similarly, for your scanner printers or shared printers or something like that. Now, high cost measure is energy efficient version is replaced, or you are using a complete building energy management system in order to control every type of these equipments. Now, with this background, what we know is basically what we are doing is we are managing our energy. We are using some kind of efforts in order to manage our energy. So to manage the energy, first of all, we need to understand our pattern of energy use. What is our energy use? And this is most of the difficult thing, because we ourselves do not know that what is my use, what illumination I am needing in my office, what kind of lighting I am needed, what kind of printer I need. So what happens that the first of all, we need to understand our energy use, and then we need to plan and organize that what kind of equipment I am needing in order to incorporate energy efficiency features and energy conservation features. And then we need to implement it. So this three prime stages, that is understanding energy use, planning and organization, and implementation, is vital, because that gives us the energy conservation opportunities before our hand. But once it is implemented, we need to verify, monitor, and report, that is measurement and verification. And suppose after measurement and verification, we come to know that whatever we have intended for, we have achieved it. It means we have fulfilled our commitment, and then our cycle is complete. But if we have not fulfilled our commitment, then it means we have to re-understand our energy use. Then we have to replan and organize, and then implement new features after verification and measurement. Then we will be verifying commitment, and this will become a cyclic process until this commitment, whatever we have intended for, will be met. So this is another way of understanding the energy efficiency life cycle. It started with the planning and prioritization, then implementation and management, and then measurement and verify. The same thing which we have discussed here is written in a slightly better or transparent manner, that all our energy efficiency cycle is first we need to identify our energy conservation measures by planning and prioritize, and before that we need to understand our energy use, and then we need to apply the energy conservation measures to implement, and after that measurement and verification in terms of monitoring system, and then an evaluation is needed. So this cyclic process will continue unless until our evaluation confirms that whatever we have planned and prioritized have been achieved. So if we look at the different energy intensive process in order to get the energy efficiency, then in order of increasing investment or financial liability, this is called energy pyramid. And this energy pyramid is called leading to sustainability. So you can see that energy conservation comes at the bottom of it. It means energy conservation is less energy intensive process by which we can achieve energy efficiency. So replacing with higher energy efficient equipment is slightly more capital intensive. Change in use pattern through demand side management requires more capital investment. And finally, deploying of renewable energy is the most capital intensive process in order to get the energy conservation measures and energy efficiency measures implemented practically. Now, if you look at the Paris Agreement and correlate these activities with the 17 cross-cutting goals which has been set by Conference of Parties, these are the 17 Sustainable Development Goals. Behind this, there are 53 clear-cut targets, but energy conservation measures directly is related to these 4 Sustainable Development Goals, that is sustainable cities and communities, responsible consumption, climate action, and finally related to renewable energy. So energy conservation for sustainable development is very, very important, because that energy conservation measures and its deployment actually gives us an edge over the responsible consumption that may lead to sustainable cities and communities. And finally, using less of energy can give us climate sustainability, leading to deployment of renewable energy in a more wider manner. But all these activities are ultimately giving us opportunities for good job and economic growth. So energy conservation activities are having a direct relation on our sustainable development goal and whatever target we have aspired for. Always remember that if we leave the energy conservation behind, we will not be able to achieve the target of net zero by the year 2070 or the targets which is immediately required for 2030. This is another way of looking at the pyramid of energy conservation. And if you look at this pyramid, you will find that this is stacked in order of increase in investment. So understanding our pattern of energy use is the first thing, and then implementing low cost or no cost measures, targeting lighting equipments. These are the basic building block of energy conservation measures, which can be done by anyone. Yeah, like you, me, a layman, anyone can target for this one. Now, after this, the ceiling of the envelope, which can of the building, which can increase our thermal comfort, or you can say it is disconnecting our building or the occupied space from the outer space. Using Energy Star appliances, water heating system, heating and cooling system, wall to window ratio, and finally deployment of renewable energy are the options, but you can see that as we go up, the complexity will increase and it will require more investment. So I always say that actually, first of all, we need to understand our pattern of use or our energy use, implementation of low cost and no cost measures in 3 kind of equipments, not only lighting, but lighting, office equipments and kitchen equipment is everybody should target for, because that will lead us to the sustainable development. These are no doubt some of the options, but requires skilled personnel and as well as requires more investment to be done. So these are some of the 7 initiatives by Government of India in order to promote the energy efficiency and energy conservation through BEE. The first thing is labeling of equipments. So energy leveling in terms of star level equipments are available into the market. Some of them are mandatory, some of them are voluntarily. We can go for higher star rating, but obviously that needs to work out on your economics. That is how much finances available with you. Energy conservation building codes earlier is mandatory for commercial sector, but now it is also available for the residential sector. And if we can implement those ECBC codes, and these ECBC codes, based on that, the building is certified by GRIHA, which is Terry's own rating system, or LEED and ASHRAE as international rating system, then we can conserve some more energy. National Mission for Enhanced Energy Efficiency was one of the program under National Action Program for Climate Change. And the first is PAT scheme, that is called Perform, Achieve and Trade scheme, which is mandatory for the industries. Then making transformation for energy efficiency financing platform and framework for energy efficiency economic development are some of the efforts of Government of India in National Action Plan for Climate Change under enhanced energy efficiency they have implemented. Then NCRT has put some of the text into a school level so that the school children can be motivated for energy conservation. Capacity building programs and Ujala scheme, which brought down the price of LED bulbs to affordable limits, are another schemes. Recently, FAME 2 under National Electric Mobility Mission Plan are launched in order to promote electric vehicles and reduce the dependency on fossil fuels primarily, are another effort. One more initiative which I have not listed here, which was the Energy Conservation Amendment Act Bill 2022, which is recently placed, where energy conservation activities have also been related to energy carbon credit markets. That is, more using energy more conservatively can lead you to some earning of carbon credit certificate, which can be converted into tradable mechanism. So as of now, there is no carbon market available, but in the days to come, certainly the carbon market will be matured. So energy conservation bill basically gives us the facility that energy conservation activities can be converted into a tradable certificate. So as a conclusion, our implementation of a structured energy audit and implementation of energy conservation measures offers multiple benefits to any establishment, whether it is a residential building, a commercial building, an office building, an institutional building, because it will provide improved energy efficiency, which has the potential to reduce the overall energy bills. It reduces the environmental impact because we are using less of energy. Because we are using less of energy or for a less time, that same equipment, it reduces our O&M costs, and it improves our working condition and maintains the safety. And because it is not that we can do it in isolation, we need to do it collectively. So it gives an opportunity for a greater organizational involvement and competency concerning the energy issues. So this is an opportunity where everyone working in an organization or institution can come up together to conserve large amount of energy, leading to sustainable development. So with this, I come to the end of my presentation. As introduced earlier also, I belong to Terry School of Advanced Studies, which is earlier known as Terry University. It is a deemed to be university in New Delhi, which offers only master's and PhD program. My personal involvement is in MTech Renewable Energy Engineering and Management programs at Terry School of Advanced Studies. Thank you very much. I think I have not
Thank
taken
you,
much.
Dr. Naqvi, for a
Time.
wonderful presentation. And on a short notice, you were able to accept our invitation. We are very, very thankful to you, Dr. Naqvi, for interactive session with the participants. Dr. Shaheen, you may request the participants if somebody would like to know something.
Yes, sir. I request from the participants, if they have any questions, they can ask.
Sir, I have a question.
Please.
Hello. Can you
Yes,
hear me?
please. Please ask the question.
Okay, sir. Sir, I have a question regarding this. The number of schemes available in the government of India for the development of it. How can achieve this activities, or how to develop this programs with the government of India? Sir, can you procedure?
Okay.
Can you provide the procedure regarding, sir?
Yes. So thank you. And this question will give us some more knowledge about how we can use those schemes basically. So see, there are two types of efforts. There are two types of schemes available. One scheme is some of the schemes are on institutional level and some of the schemes are on individual level. All these energy conservation schemes are basically governed by Bureau of Energy Efficiency, which has a dedicated website. Now, if you want to use those schemes for a commercial benefit for your industry or for your establishment, you need to apply for those particular schemes or subsidies through that particular website. Second thing is you need to, like, say, understand how to go ahead with a particular scheme and whether that scheme is applicable to my kind of establishment or my institution or not. So again, you need to refer to BEE website, where you will have a section on all these schemes, and that section will give you the standard operating procedure in order to get the benefits of that particular scheme. Some of the schemes for the industries are mandatory, like say PAT scheme or Ujala scheme or other schemes that is mandatory for the industries. So in that particular case, industries already know that during the establishment, we need to take these kind of certification, and the process of those certification is again available into the BEE website. So what I recommend that you visit the BEE websites, that is Bureau of Energy Efficiency websites. On that particular website, you will get all these schemes and also the SOP to apply for a particular scheme. Hope that clarifies your answer. Doubt.
Sir, it is for all institution level, or sir, particular institution, just like NIT, IIT or other things of institution can benefit from this BEE websites or related to these projects, or any
No.
institution can apply for this? Any criteria, sir, for this?
No, as of now, there are no criteria. There are no eligibility criteria. The only thing is, because it is as of now voluntary for educational institutions and residential sector, all these things are voluntary. So there are no eligibility criteria. You will find that anyone can go for that one. In fact, I would recommend that we should also look at BE website. There is a course on certified energy auditor. So if you apply for that certified energy auditor, if you get that certification, you will be officially a manager in order to assess any particular area to look for energy conservation opportunities. So as of now, there is no eligibility criteria, there is no prerequisite, and anyone can go for that one. And that will also give you an advantage while you will be going for your NAC assessment or NBA accreditation.
NAC, sir, NAC or NBA is mandatory for this, sir?
No, it is not.
Okay. Okay, thank you very much, sir.
Sir, thanks a lot.
Yes.
Sir, thanks a lot.
Thank you very much.
Sir, very informative lecture and knowledgeable lecture. I was scrolling through your profile. With that, I can say you are more than doing justice to your very respectful job. Actually, whatever interactions we have had with you have been very fruitful to not only to the students, but also to the faculty members who want to pursue their research work, actually, in the field of renewable energy. Certainly, we would like to have more interactions with you in future, sir. Again,
yes,
thanks a lot,
sure.
sir.
I would love to visit your campus personally sometime.
Yes, sir. Definitely. You are invited, sir. Thank you, sir.
Thank you. So I think I can leave now.
Sir, it's your choice, sir.
Okay. Thank you very much. And thank you all for giving me this opportunity to share my thoughts. Personally, thank Dr. Rafi and Dr. Shaheen. Thank you very much.
Thank you, sir.
And wish you a successful conference.
Thank you, sir. Now, we have the second keynote speaker with us, Dr. Mohammad Nizamuddin Saab, who is professor in Department of Electronics and Communication Engineering, Jamia Millia Islamia, New Delhi. Dr. Mohammad Nizamuddin has completed his PhD in VLSI and Nano Electronics, MTech in Nanotechnology, and Bachelor of Engineering in Electronics and Communication Engineering, triplet from the Jamia Millia Islamia, New Delhi. Dr. Nizamuddin is working as professor, as I mentioned, in Department of Electronics and Communication Engineering, Jamia Millia Islamia, New Delhi, since 28th March 2020. He is Deputy Coordinator, Admissions and Deputy Nodal Officer, NAD, at Jamia Millia Islamia. Earlier, he has worked at several reputed places, including Assistant Professor in Senior Scale in Electronics and Communication Engineering Department of our college, that is Mecw Engineering College, Waqf. Dr. Nizamuddin got several Best Research Paper awards in reputed international conferences, filed 2 patents titled as Electromechanical System and Method for Information Compression and System and Method for Low Cost Microscopy. He has published more than 100 research papers, book chapters, including several SCI papers. Dr. Nizamuddin has guided 1 PhD scholar and 6 PhD scholars are pursuing their research work under his able guidance. He has also worked as training and placement officer at our college, that is Mecw Engineering College, starting from 2012 to 2016. Further, he has organized several conferences, seminars over here as well as in Jamia. His field of interest includes VLSI devices and nano-electronic circuits and embedded system. So I invite Dr. Mohammad Nizamuddin Saab to deliver his keynote speech. Welcome you, Dr. Mohammad Nizamuddin Saab.
Thank you, Dr. Shaheen
Over
Khan.
to you.
Is my screen visible?
Yes, Dr. Saab.
Okay, thank you. Honorable Director, Professor Khwaja Mohammad Rafi, respected heads of Department of Electrical and Electronics Engineering, and Department of Electronics and Communication Engineering, Mecw Engineering College. Honorable dignitaries, participants, and young research scholars. I, Mohammad Nizamuddin from the Department of Electronics, Jamia Millia Islamia, would like to tell you something about the future of electronics. Before I proceed to my lecture on the sad topic, I want to know what is the time limit. Accordingly, I will plan the things. Please, Dr. Shaheen Khan.
Yes,
Back to you, please.
Professor Saab, you can continue as per your wish, but the time limit is around 50 minutes.
50 minutes. Your 15 minutes.
Yeah, 50 minutes.
50 minutes. Okay, okay. Thank you, thank you. As the title of my talk represents itself, beyond CMOS device technology, future of electronics devices. This is a big question before all of us, because we do prefer miniaturization of the things. It is preferable to have the complete automation is complete setup on the chip spending day by day. We, the people of electronics field, especially nano electronics devices, are worried due to the limitation of the current technology that is based on silicon. Although silicon is easily available, abundant in nature, has maximum research publications as we compare with all other semiconductor materials, still we can't use it in near future as per our requirement due to the short channel effects. As we are going to miniaturize the things, in that case, we are reducing the size of the devices, which are the fundamental or the basic building block of all electronic gadgets. So I would like to emphasize on how to replace the current solutions with the future ones. So this is the outlook of talk. As we know, before a researcher or a designer is design objectives. What is our target? What do we want to achieve from any implemented idea? So the first thing I would like to explore is electronics design objectives. What are the objectives which a researcher must keep in his or her mind before designing something new or add something in the existing system? Of course, this is the reason for choosing the topic setback of MOSFET technology, which is in fact CMOS. Then this is the ultimate solution in terms of carbon nanotube, which is one of the solutions. And I will explore its properties, applications, and the most important application, especially in the field of nanoelectronics. And then how to use this device, CNT-FET, which is basically made up of carbon nanotube in electronic circuitry. And the ultimate device is CNT-FET based operational transconductance amplifier. And then finally, we will compare the results of the existing technology base, that is CMOS based, with this latest or the innovative CNT-FET device. And finally, its applications before going to conclusion. This is the flow of my talk. You can see here the fundamental device, which is the replacement for CMOS, is CNT-FET. We will discuss about the model first, and then its application from circuit point of view. And this circuit will be then implemented for key electronic applications. So as I have already told, a designer must have in his mind all these design objectives. The foremost and the most important aspect is size. We want our device to be compatible. We want our device to be portable, consume less space as less as possible. And of course, another important aspect is power dissipation. We do prefer the device which is having minimum power dissipation. So the device which I'm going to explain is having extraordinary power dissipation. It is having almost negligible power dissipation. Then based on its structure and the material used, our device is having excellent speed. We are going to discuss this later on. Similarly, functionality, we want whatever solution we are going to propose, it must outperform the existing one in terms of functionality as well. And ultimately, we know well that initially the cost of electronic gadgets is high, but as the time passes, the cost reduces with time. Large noise margin, it must not have an impact of the environmental unwanted signals. And finally, reliability and long lasting. We know well that there was a dream of Feynman's, a renowned scientist in past. He dreamed, why not the entire encyclopedia of 24 volume should not be on the tip. And from the dream of Feynman, today we are having the things which are readily available and we are using in terms of short compact devices at all, like this. These are the compact devices which we are using. It was a dream of Feynman. And this dream was further analyzed by Moore's law. I need not to explain it in detail, you know well. So how to proceed, keeping in mind the dream of Feynman and Moore's law, the first step was conventional technology in terms of CMOS, which is called bulk technology or CMOS technology. Presently, we are using in most of the electronic gadget this bulk technology because it is a mature one. Mature means we know each and everything. If we know each and every aspect from design point of view about a material or corresponding device which is designed based on that material, we need not to take any risk. We can use it as per our design. We can have a prototype as per our requirement if we know each and every design parameter of the material or device which we are going to use. Of course, it is having low cost and thermally efficient. But the problem, which I've already told you, is realization at nano scale. When we shrink the size, when we shrink the size or the channel length, there are the problems which are called short channel effects. We are not having the control of this gate because bulk technology or the CMOS technology is based on VGS voltage. We do control the output current by gate voltage. If the gate voltage is not having optimum control over the channel, the device is not useful. So when we shrink the size of this gate, then these short channel effects exist, and we do have a number of issues like reliability issue, leakage, increase in power dissipation, and these are the few. So keeping all these issues in mind, we are unable to use CMOS in nano electronics devices. So we have to go for alternates. So the alternates are these. Due to scarcity of time, I'm not able to explain all the devices in detail. That's why I choose the single one, that is CNT FET. We'll discuss it in detail. Another one briefly I would like to explain here, which is graphene nano ribbon field effect transistor, which is very much similar to the carbon nanotube field effect transistor, which I will explain here. The third one is single electron transistor, which is going to bring the revolution in the semiconductor industry in near future. At present, we know well there are 10 to the power of 15 charge carriers or more. To change the bit from low to high, we are having millions of transistors to change the bit from low to high or high to low at present. But that would be possible by moving of an electron from one island, from one state to another state using a single transistor. So this technology is premature and simulation is going on, but in near future, we will have dramatic change in the electronics industry by the application of this single electron transistor, which in short is the role of a single electron will decide whether the bit is high or low. And another alternate to the CMOS is FinFET. FinFET, and I will explain it here. And ultimately, we are going to have one more device that is called magnetic tunnel junction, which is having the magnetic effects. So let me briefly explain GNRFET. This is the GNRFET. In this graphene narrow ribbon field effect transistor, this is the source and this is drain. We are having a single atomic layer of graphene in place of N-type or P-type channel, or we replace the N-type or P-type channel by graphene sheet. This is a graphene sheet. So all the features of the graphene sheet are basically part of the device GNRFET. Similarly, in this FinFET, which is another alternate and being used in mobile technology at present as well, here the control of the gate, which is the backbone of FET based technology, here the control of the gate is more in FinFET as compared to CMOS. You see here, this is our source and drain. Between these source and drain, we are having the three-dimensional control over the channel. But in case of FET, we have the upper one or the lower one as per our requirement. But here we can cover it in a best possible way. So the topic of my talk especially was CNT-FET. CNT-FET is a device which is basically possible due to an innovative material that is called carbon nanotube. So what is carbon nanotube and how to use this carbon nanotube in CNT-FET? Let's discuss. You see here, the carbon nanotube are basically classified in two categories. The first category is based on number of tubes. This is single wall carbon nanotube and this is multi-wall carbon nanotube. Here we are having one carbon nanotube inside another having different diameters. So these two type of carbon nanotube, and this single wall carbon nanotube is made of from this graphene sheet. When we roll this graphene sheet at 3 different angles with different indices. Yeah, you see here, let me tell you by taking an example of a paper. When let us suppose we are having this paper here. When we roll this paper at 3 different angles, like as shown in the diagram as well. And this graphene sheet like this is another type of carbon nanotube. When we roll this paper at this third angle between 0 and 30 degree, so it becomes the third type of carbon nanotube. Suppose, please pay attention. Let us suppose these are two atoms, and in these atoms we are having electrons. We are having, and when I roll this carbon nanotube like this, so in that case, the force of repulsion and the force of attraction is X. When I roll this carbon nanotube like this, a little bit attention is required to know the concept of how the carbon nanotube is being used. When we roll this, the force of attraction and the force of repulsion will be different one. That is suppose Y. And when we roll it like this, the force of attraction, the force of repulsion will be different one. I mean to say, when we roll a single atomic layer, which is called graphene sheet, at 3 different angle with having 3 different indices, then this sheet will be converted into different type of carbon nanotubes, and these 3 type of carbon nanotube will behave differently. Why is it so? The reason behind it is because we are having different force of attraction and force of repulsion, and based on this there would be different density of states. If the density of a state is different, then of course the band gap, which is called energy band gap, will be different. And if the energy band gap is different, of course we know the concept of whether the material is semiconducting, conducting, or insulating. The totally based on the band gap. If the band gap is less than 1 electron volt, we know well it behaves like a semiconductor. If it is greater than of equal to 5 electron volt, it is treated as insulator. And if they overlap each other, valence band and the conduction band overlap each other, in that case it is treated to be the conductor. Similarly is the concept over here. When we roll this carbon nanotube, this graphene sheet at 3 different angles, it behaves differently. And from this concept, we are having 2 especially used and the most prominent carbon nanotube, which are made up of a same material as conducting or semiconducting. This is the beauty of this carbon nanotube, which can be used as a conductor or as a semiconductor. So this beauty of this carbon nanotube is used in the fabrication industry. At present, what we are doing, we need semiconductors for designing or fabrication of devices. But for interconnects, for device fabrication, we need semiconductors, and for interconnects or the wires, for IO ports connections or the connection between 2 devices, we need interconnecting wires. But at present, what's happening? We are using different material for wires and different one for devices. But when this technology will be mature one, like CMOS technology, then we need not to use 2 different materials. Simply, it will result in the simplified device fabrication. So this is written well. I'm not going to in detail. I have told you the concept. So, and the conclusion of this slide is the same material, if rolled differently, will behave like conductor or semiconductor. And hence we can use it for our non-electronics applications accordingly. So as the first point itself indicates, which I'm telling you, the exceptional property of the carbon nanotube in case of electronics industry, all these features are basically related to electronic applications. So the first one is metallic or semiconducting. So we will use this metallic feature of this carbon nanotube for interconnects and device fabrication as a semiconducting one. And the second point itself reflects the things which I'm telling you. Apart from it, as I have told you, we need a speed. CNT FED has higher speed, 4 times higher mobility than silicon. Of course, the speed would be higher. The diameter of carbon nanotube, this diameter of the carbon nanotube can be controlled by chirality, indices. I'll tell you with the formula as well. I proved the things. And another important feature is thermal conductivity is greater than pure diamond. That's not so important from electronics point of view. And then we are having another application of field emission display. And the last one is current carrying capacity. The current carrying capacity is better than copper. So we will use the same material for interconnects, and it will having more current carrying capacity. It will not burnt out easily. Of course, it is a premature technology. I would like to tell you again and again, it is in infancy stage at present. So the problem behind this exceptionally well technology is its growth. For device fabrication, we need aligned carbon nanotube. It must be straight to replace the existing CMOS, existing silicon-based channel by carbon nanotube. We need aligned carbon nanotubes or straight carbon nanotube. So the growth of straight carbon nanotube is becoming a toughest at present, but it will be easy in the near future. And as I have told you, there is a diameter is controlled by chirality. So it is becoming a tough to have the diameter of desired nanometer. That is another drawback at present. Of course, this is a new material which is invented by accident, not with intention, by a Sumio Ijimiya, a scientist. So that's why we do not know about the health hazards of this new material. And of course, the production of this device is at present relatively expensive as compared to the other silicon based. These are other exceptional properties. I would like to skip this slide. Have a look, please. The strength is 45 billion Pascal. You see, the steel allow are 2 billion Pascal. So it is better than that one. Elasticity, it can be banned. Okay, it can be easily banned. It is not fragile. This is another important aspect. So, and current carrying capacity, which is very much related to electronics, is 10⁹ ampere per centimeter square, which is higher than the copper's one. You see the copper's one here. And thermal conductivity is, of course, better than diamond, which I have already told you in the previous slide. These are the predominant important applications. From all these 11 significant applications of carbon nanotube, we can have a research projects. These nine are basically the field of research, and I'm talking about the first one, that is the role of carbon nanotube in nanoelectronics devices and circuits. So the beauty of using this carbon nanotube based device in nanoelectronic circuit is written very much here with the red lines. Can be it can be easily the CMOS technology will be used as a hybrid technology with this CNT-FET based technology. And we need not to have a separate infrastructure for fabrication of these CNT-FET based devices. Another application is field emission display. Okay, as I have told you, an important application of this CNT is SET, which is based on the controllable transfer of single electron beyond imagination. Single electron between small conducting islands. Basically, in case of SET, the concept of Coulomb blockade is used. Based on the concept of Coulomb blockade, when the one transistor will move from one island to another island, the bit will be changed. And the fourth one is wires and conducting composites. As I have told you, the CNT wires can successfully use for power data transmission, and the reason behind it is written very much here. Composite of CNT and copper have been shown approximate 100 times higher current carrying capacity than pure copper. We can see here. So it's of course the device speed will be higher. The fifth point is another important field for the people who are working in mechatronics, or who want to club the mechanical with the electronic one, that is nano electromechanical system. It is basically the expansion of MEMS, micro electromechanical system, where we are having electronic equipment along with mechanical equipment along with electronic circuitry. In case of MEMS, we have electronic circuitry one side and mechanical equipment another side. So that electronic circuitry where we are using micro technology at present are being replaced by nanotechnology. That's why it is preferable in case of NEMS applications. We know the airbags where we are using in cars, airbags use MEMS. So in near future, we are going to have a smaller size of MEMS by using NEMS. Of course, another important features of the carbon nanotube is its highest reversible capacity, which is playing the vital role in the application of batteries. Space elevator, as I have told you, this is having very high tensile strength. If we compare the strength to weight ratio, it is said about this carbon nanotube that if there is a possibility of a ladder from Earth to Moon, that is possible using carbon nanotube. I'm repeating it. If there is a possibility of ladder from Earth to Moon, that is possible using carbon nanotube in future. And of course, other parameters are which are not related to you people. That's why I'm going to skip this slide. This is scarcity of time. So the main topic which I would like to explain, and I need your attention, please, especially those who are working in the field of nanoelectronics. You see here, this is basically the 3D structure of carbon nanotube filter effect transistor. You see here, we are having a source and drain. Between these source and drain, we are having n number of CNTs as per our requirement. So see, earlier what was here, the channel was made up of silicon, N-type or P-type depending on our requirement. So the channel which was made up of silicon is being replaced by CNT. So these CNTs, the current will flow from source to drain as per our requirement through these carbon nanotubes. And all the features of the carbon nanotubes will be utilized by this technology. So here there are three important design parameters of this CNT FET. The first one is number of tubes. If we will increase the number of tubes, of course, the current will increase. Another aspect is its diameter. If we will change the diameter, then the width will change and hence the current will change. I'll prove with the equations as well. And the third one is inter-CNT spacing. Inter-CNT spacing means, you see here, please have a look. This is one carbon nanotube and this is another one. So inter-CNT spacing means the distance between the centers of two adjacent carbon nanotubes. So you see here 1 and 2. So the distance between these two carbon nanotubes is called pitch, P-I-T-C-H, pitch. It is very much written here, which ultimately affects the width. So from this description, let's have a look on the significant features and the advantages of this carbon nanotube. It is carbon Carbon nanotube is a has one-dimensional ballistic transport of charge carriers. And due to this ballistic transport, bullet, here we are having the concept of bullet. This ballistic transport, due to this ballistic transport, we are having very high mobility and a large drive current, which results in frictionless movement, and hence mean free path will be very high. And of course, if the mean free path is very high, the charge carriers will travel without any interruption, resulting in negligible power dissipation, which is the need of time. Another important feature of this device is similar working to conventional MOSFET. Concepts, architecture, or the infrastructure is similar to CMOS. With the only difference that we are replacing the channel by this tubes, carbon nanotubes. We are replacing the channel by this carbon nanotubes. So due to all these features, CNT FET circuits with 1 to 10 CNTs per device is about 2 to 10 times faster as compared to the CMOS. And similarly, we are having very low power dissipation. I prove with all these features with the example, and which have been published in very reputed journals. I'll tell you later on. You see here, please pay attention. This is the equation for current. You see here, from this current, N is the number of tubes. When we increase the number of tubes, of course, the current will increase. Transconductance, GCNT is transconductance per CNT. Okay. When we will increase it, of course, the current will increase. And these are the conventional terms. Rest of the things are conventional one. VDD, VTH, and LS and ρS are length and resistivity of source side. This is very important equation. W equals to N minus 1 within bracket S plus D. Here, W is the width. N is the number of tubes. S is the pitch. This one, inter-CNT spacing. And D is the diameter. These three parameters, design parameters, I should say here, these three design parameters will play vital role in the performance measuring parameters of this device. Okay, you see here, it was also told earlier that this is effective one. You see here, EG, band gap, energy band gap, is inversely proportional to diameter. So of course, when we will change the diameter, EG will change. And this dia is controlled by chirality. So ultimately, if we will change the chirality, the type of material will be changed. This is the beauty of this device. Again, I'm going to repeat, which was not clear in the previous slides, the three important parameters: pitch, width, and tube, number of tubes. I hope it is clear from this diagram now. Let's have, this is basically how the carbon nanotubes are grown, are produced. Okay, how to synthesize the carbon nanotube. I will explain the first one. You see here, these are the, this is the chamber where I'm having a sample or the substrate. This precursors will move in this chamber, and due to very high temperature of 270 degrees Celsius, right, they will break down and the carbon nanotubes will deposit over here on this sample. And we will see these carbon nanotubes using smart or the modern telescopes, sorry, microscopes, which is SEM, SEM, scanning electron microscope, AFM, TEM. There are other instruments as well to characterize these grown carbon nanotubes. So how to use this carbon nanotube based CNT FET in electronic applications? So here I have taken an example. So You see here, we will use this carbon nanotube for designing of an important basic building block of electronics that is called operational transconductance amplifiers. So to design this operational transconductance amplifier, we will use HSpice software. HSpice software for designing this operational transconductance amplifier, we will have different models at 45 nanometer technology node. The first model, which is highly accurate and named Verilog A Stanford model, will be used for CNT FET transistors, and for CMOS, we will use BSIM B4.6.1 BPTM model at the same technology, 45 nanometer technology node. So we will simulate and see the results. After simulation, we are having the results, and it is proved that when we use this CNT FET based model, in place of this BSIM BPTM model, the results are very, very satisfactory. Let's see now. CNT FET based operational transconductance amplifier design, which is going to improve the performance of conventional CMOS OTA based design. So here we are going to design the 4 models. This is pure CMOS based or the conventional technology based operational transconductance amplifier. It is having 2 types of transistors, P-type transistors. The upper 4s are P-type, pull-ups are P-types transistors, and these are N-type transistors. So the first proposed model is having the same PMOS transistors. Here you see here, but the NMOS transistors are replaced by N-type CNT FET transistors. You see here. In the another model, we have replaced the PMOS transistors by P-type CNT FETs, keeping the NMOS transistors same. You see here. In the last model, which is called pure CNT based OTA, all the existing CMOS based transistors, P-type as well as N-type, were replaced by CNT FETs. So let's have a comparative analysis after simulation of these 4 models, and it will be very much clear to all of us that the proposed models are better as compared to the existing one. Let's see. As I have told you, here we are having the comparison among the proposed models only based on the 3 important parameters: number of tubes, diameter, and pitch. So of course, I would like to tell you these 3 design parameters are not in this model. That's why initially I'm not going to compare this model with the proposed ones, but we will compare all these proposed models from each other. You see here, when we increase the number of tubes, we can see from this sketch that the pure CNT based OTA is having maximum gain as compared to the hybrid technology based. The red one is where we were using NCNT FET and PMOS OTA and PCNT and MOS OTA. Similarly, you see here, in this case, it is very much reflecting that the power dissipation is unexpectedly low. You see here the power dissipation of the proposed one. Pure CNT of FET OTA. This one. The power dissipation of this is extremely low as compared to the hybrid one. We are getting, this is due to the ballistic transport. Similarly, when we see the comparison of output resistance, which is another important design parameter. In case of OTA, when we see the ideal OTA, it is preferable to have high output impedance. So you see here the output impedance is higher in case of the pure CNT OTA, and the drawback is smaller bandwidth due to the screening effects of the capacitances which are basically formed between adjacent carbon nanotube. We are having low bandwidth. This is the drawback of this technology when we use it in OTA. Similar is the variation of all these design parameters. I will skip all the slides, but to have a look for you, I have included. You see here, in this case, what we are having, we are changing the diameter and getting the response accordingly. All four graph, you see diameter change. In this case, pitch change, variation in the pitch. This is again the variation in the pitch. Ultimately, stability analysis, I'll tell you with the tabular form. Let us have a look here, which I have explained in the figures or the diagrams. This is a tabular comparison of the existing technology, CMOS OTA. You see here, CMOS OTA. So here the gain, keeping the design parameters same. While you are going to compare two things, it must be with the same design specifications. We can't compare apple with orange. We can compare the apple of Srinagar with the apple of Shimla. Similarly, if we are going to compare two different technologies, the design's parameters must be same. Only then the comparison is fruitful. So keeping in the design parameters same, we can see that there is a drastic change in the design parameter, in the performance measuring. These all are performance measuring parameters. Keeping the above design parameters same, we can see the performance measuring parameters of the proposed technology, which is having extraordinary. Technology is having 12.6 dB gain, but the pure CNT based OTA is having 40.3. And in other two as well, the gain is high. Only drawback is due to the screening effect. Only drawback is bandwidth. We can see the another important aspect in electronics industry is power dissipation. We can see here the power dissipation is 15 microwatt, but it comes down to 82 nanowatt, unexpected. Similarly, we can have the look on the output impedance, that is 3.35, but here 5.2. Of course, slew rate, which is increase the speeds. So all these design parameters prove that the proposed technology is better than the existing one. Apart from it, as I have told you, first we have discussed about the material that was basically carbon nanotube. Then it's device fabrication in the name of carbon nanotube field effect transistor. And from this CNT-FET, we have designed OTA. And from this OTA application, band pass filter. So again, when we see the band pass filter, all these frequency response of band pass filter, we can see the quality factor is better in case of CNT-FET based band pass filter. So from this discussion, it is concluded that if we are replacing a single material, the corresponding effects are observed everywhere in the electronics. So this is another example. By changing the existing OTA or by replacing the existing OTA by the higher version that is called cascode operational transconductance amplifier. I will skip it completely due to the shortage of time. See, this is conventional OTA. Here, the same pattern is applied. We have replaced the conventional cascode OTA by three models, which was earlier discussed. Need not to explain. And the beauty of this work is here we have compared the previously published work with this Cascode OTA, and it is concluded that the Cascode OTA is having better result with the already proposed OTA. So these are the result with all the three design parameters. I need not to explain here. You see, this is already published, but CNT-FET OTA. Here we were having 40.3. In the previous case, it is increased further. Bandwidth, of course, will decrease. Output impedance also having higher. Okay. The reason for this 38.35. Okay, you see here, all the parameters are comparatively better in case of further modified OTA, that is called Cascode OTA. Again, we are having the same application using Cascode OTA. Comparative analysis of that. So this is the conclusion. I have told you about initially carbon nanotube and application of carbon nanotube in terms of CNT-FETs. We have discussed about this device which is applicable in the designing of operational transconductance amplifier as a circuit. We have discussed all these parameters, and then we have designed band pass filter using carbon nanotube OTA. And then to have a comparative analysis of the proposed technology with the higher version of the conventional technology is also proved like this. And this was finally, these are the references. Thank you. With the permission of chair, I would like to tell you about the codes, if possible. Otherwise, I just stop here.
Thank you, Professor Nijamuddin Saab. I think if students have questions or any participant has any questions, they can ask, because we have to move for the another lecture of Professor Rizwan sir. He is waiting. So I request from all the participants to ask questions if they have any. Participants, please, if you have any question, please. So thanks a lot, Professor Mohammad Nijamuddin Saab. Your inputs are very informative and very informative lecture to students and faculty members who want to pursue their research work in electronics area. You have been marvelous here at Mecw Engineering College and involved in many activities beyond your role with positivity. This looks to be the reason Almighty Allah has blessed you with your current role. You are still serving MECW, being the supervisor of one of our faculty members here. We at Mecw Engineering College are proud of you and wish you best of luck in your future endeavors. Thanks a lot.
Thank you, Dr. Sain Khan, and I would like to thank you and especially congratulate you people that you have organized such a wonderful conference. And I am sure that the picture will not stop here. It will go ahead. In near future, you will organize more conferences with the collaboration of our department. I have discussed with my head of department as well, and he is very much ready to organize international conference in collaboration with MEC. Thank you. Thank you once again.
Thanks a lot, Nijamuddin Saab.
Okay, thank you.
Then for today, we have another lecture, Professor Mohammad Rizwan Khan. He has received his BTech in electrical and MTech in electrical and PhD degrees in 1998, 2001 and 2009 respectively from the Aligarh Muslim University, Aligarh. He is currently a professor in the Department of Electrical Engineering, AMU, since 2001. His principal area of research interests including power electronics, artificial intelligence, and multi-phase motor drives. He is involved in the teaching at postgraduate and undergraduate level of electrical engineering courses and actively participated in the research activities in the field of power electronics, electrical machines, and drives. He has published a number of papers in the reputed journals like IEEE Transactions on Power Delivery, IEEE Transactions on Energy Conservation, Conversion, and many more. He is supervising many PhD students. So it's our privilege that Professor Muhammad Rizwan Khan Saab is with us and he is available for lecture. Sir, over to you. You can start your lecture keynote speech. Sir, can you hear me?
Just wait.
Thank you, sir.
Yes, sir. I'm just trying to add my slides.
Sir, can you please share your screen, sir? If it is.
I think now it is visible.
Yes, sir. It is visible, sir. You can start, sir.
Good. No, this is very good. Very good afternoon, all of you. And first of all, I would like to thank you, all the organizer for conducting this international conference, Rtreaet 2023, especially the directors, Professor Fazal Rafi and Mr. Organizer, Mr. Shaheen Saab, and all the members, all the participants, faculty members and residents. Because time is very short, already I will lose 15 minutes. I have only 45 minutes. I have to anyhow I have to complete by 1 p.m. So may I start my presentation?
Yes, sir. Yes, sir.
Okay, so today's presentation title is Energy Transitions. What is the role of RES, renewable energy sources and electrical vehicles?
ये पहली स्लाइड होती है ना, ये बड़ी इंपॉर्टेंट होती है.
So the outline of the presentations are: what is the introduction about the energy transitions, then energy transitions, its overview, and the drivers for the changes, the role of RES, and the simulation case studies of EV impact on the IEEE buses, and the conclusions. First of all, I would like to explain what is energy transitions. I want to explain. Energy transition is a historical phenomenon. You can say the current energy transition is basically motivated from the degradation of environmental conditions, and the goal is to make decarbonized society by achieving the net zero. What do you mean by the net zero? Net zero means we should use fossil fuels as a zero. No fossil fuel used for the generation of electricity. That is the power. The ET is a scientific, it is a technical, economical, governance, and societal changes also. And there are 6 major pillars which are used in energy transitions. That is basically we have to transfer the way of generating the energy from the conventional mode to the non-conventional modes, so that this net zero target can be achieved. That is the decarbonized society. What are these pillars? When we use the power, the transportation sectors, the major area where we are using this power. Second, electricity generation, but it should be clean. It should be a very much clean energy generations. Hydrogen economy, that is from brown to green energy. The decarbonization of the current hydrocarbon business. The industrial sectors and policy and governance. So basically, these are the 6 major pillars in energy transitions, where we have to transfer the type of how to generate the power from one mode to another mode. How to enable this? How to make this energy transition possible? The energy efficiency enhancement and by power electronics projects. With the help of these 2 targets, we can achieve it. And second, the carbon capture. We should capture the carbon, means carbon emission should be as minimum as possible. And the green hydrogen economy, that is, we should move to the green hydrogen productions, because with the help of this technology, the emission of carbon is much less as compared to the others. Then the circular economy and integration of RES, renewable energy generations, with the existing system, and inclusion of AI, artificial intelligence, and digitizations. Then societal awareness and social science. Then agent-based strategies, fair management of communities, and the storage, electric transportations, and uses technology. So keeping in mind all these things, we can transfer the way we are generating energy from the conventional to the non-conventional type of energy generations. What are the impact on environmental without energy transitions? If you are not converting the way of power generations, so what are the impact? According to the National Climate Assessment, human influences are the #1 cause of the global warming, especially the carbon pollution caused by burning of fossil fuels such as oil, gas, and coal. And the carbon dioxide, methane, and other pollutants released into the atmosphere act like a blanket, that is a trapping of sun's heat and causing the planet to warm. This is known as the greenhouse effect. Therefore, we must change the way the world produces and consumes energy to determine harm to our society and the natural environment. So, we must transition away from the fossil energy sources to renewable energy ones, and greenhouse gas emission must be reduced, or we can say this should be stopped. To maximize the share of renewable energy such as wind power, water power, solar power, biomass, and on the other hand, minimize over time to share the share of non-relevant energy sources like oil, gas, coal, and nuclear power. Otherwise, our global climate solution will be just pretentious. So the change is urgently required in our energy policy. It is a must to manage the natural resources on Earth. The energy demand must follow the supply of renewable energy. And this is the only way to implement sustainable living. Otherwise, we have to face the consequences, because we are so much we are producing the carbon gases. Therefore, the energy transition is a pathway towards the transformation of the global energy sector from fossil-based to non-carbon by the second half of the century, about 2030 or 2050. Renewable energy and energy efficiency measures can potentially achieve 90% of the required carbon reductions. In UN, United Nations, they conduct a conference, climate change conference, COP27, and it was held in Sharm el-Sheikh, Egypt, in November 2022. And next is proposed in Dubai, COP28, next year. In this summit, COP27, all countries agreed on the Glasgow Climate Change Pact to keep 1.5 degrees centigrade alive and finalize the outstanding component of the Paris Agreement. So the conference outcome was to achieve net zero target by the mid-century and keep 1.5 degree within reach. Should not increase more than 1.5 degrees centigrade. So the key outcomes of the COP27, that is a climate change conference, was to calculate the loss and damage and keep within 1.5 degrees centigrade. They also give, that is a food security risk, climate tipping points, and World Bank reforms. Now, if we talk about the energy transition in India, especially in India, the Asian country, the Indian government has announced a budget of 30,000 crores in 2023-24 budget for this transition, energy transition. And India has announced its net zero emission target by 2070 at the COP26 summit. That is the previous summit. Therefore, the Indian government is expecting from the developed nations to provide some finance of about $1 trillion to achieve its non-zero target by 2070. It is about 50 years, after 50 years. So India will take 50 years more to become India net zero country. Therefore, India has mentioned its steps of resolution to achieve its net zero emission target, and then India will bring its non-fossil based energy capacity to 500 gigawatt by 2030. 500 gigawatt by 2030. And fulfill 50% of its energy requirement through renewable energy sources, and cut down its net carbon emission by 1 billion tons by 2030. The carbon emission reduced by 1 billion tons by 2030. And the intensity of its carbon reduction economy will be more than 45% by 2030 and achieve net zero by 2070. And it is given that how much percentage the India will, it is 25% by 7 years and achieving 40% in the next phase. One form of another energy is the hydrogen energy. It is also very clean and green and very useful energy, and there is no carbon emission. The type of energy, just like solar energy, similarly the hydrogen energy or fuel cells. What is hydrogen energy? It is a clean energy source, alleviates environmental problems. It can be used as a fuel. The hydrogen fueled engines have advantage on exhaust emissions compared with the conventional fossil fuel engines. And fuel cell is its promising clean energy sources, the production of electricity with 30% share in this. It is a non-toxic or greenhouse gas emissions. it has 2.75 times greater energy yields of 122 kilojoule per gram when compared to the hydrocarbon fuels. Having high specific energy on a mass basis. Energy that could be produced using 9.5 kilogram of hydrogen requires 25 kg of gasoline. Now, how we can produce these hydrogen productions? It can be produced from fossil fuels, 95%, by water splitting, 4%, biomass, 1%. So the generation of hydrogen is made possible with the reliance on the both renewable and non-renewable sources. Okay, so here we can generate hydrogen from the fossil fuels, that is oil, natural gas, coal, and nuclear, but they are confining the CO2, and by the renewable energy, wind and PV, solar, biomass. By this process, we are getting the hydrogen. Percentages here: 75%, 4%, 1%. The 1 ton of hydrogen generated from coal releases 5 tons of carbon dioxide to the atmosphere. You can see, just if you want to generate hydrogen from the coals for the fuel, we are generating 5 tons of the carbon dioxide. So there are 3 steps to generate the hydrogen. First one, by methane steam reforming, or by partial oxidation, or into automatic reforming. The first one is the methane steam reforming. The basis is the reaction of natural gas with steam in the presence of an active metal catalyst. This is the chemical equations are given here, how to produce the hydrogen. And the partial oxidation, that is a term, gasification, generates hydrogen from the reaction of hydrocarbons in the presence of oxygen at a temperature of 1150 to 1315 degrees centigrade when non-catalytic, and at 950 when there is a catalytic. And similarly, it is a process where the reforming and oxidation relations occurs simultaneously for the production of hydrogen at 950 to 1100 degrees centigrade, and the corresponding related. Now, what is India's green hydrogen carbons development? The cabinet has approved an initial budget of, in India especially, 19,744 crores for the green hydrogen products. So the National Green Hydrogen Mission intends to provide direct incentives for the green hydrogen manufacturing worth about 13,000 crores. By 2030, India's mission is expected to have 5 million metric ton of green hydrogen production capability. And the goal is to reduce annually the greenhouse gas emission by 50 million metric ton of gases. This is the India's target. What are the benefits? Development of export opportunities for green hydrogen. If you are producing the green, that is the hydrogen for the production of energy, we can export, and its derivatives. And decarbonization of the industrial, transportation, and energy sectors. Reduction in dependence on imported fossil fuels and feedstocks. The development of indigenous manufacturing infrastructures. The creation of employment opportunities. and development of an advancement cutting edge technologies. Now, if you talk about different sectors, how it can be used, or how this conventional energy are using. So they step across sectors which are critical for India to achieve its net zero target by 2070. So we have around 50 years for this achieving this target. If we talk about the power sector, the supply power to the power sector, the coal-based power generation must peak by 2040 and reduce by 99% between 40 and 60 by using the coal-based power generations. The solar-based electricity generation capacity must increase to 1,689 gigawatt by 2050 and 5,630 gigawatt by 2070. And wind-based electricity generation capacity must increase to 557 gigawatt by 2050 and 1792 gigawatt by 2070. So this is the power generation by the coal-based, solar-based, and wind-based in the power sector. If we talk about the transportation sector, the share of electric cars in car sales must reach 84% by 2070, and the share of electric trucks in freight trucks must total 79% by 2070, and the rest being fueled by the hydrogen. And the share of biofuels, blended oil for cars, trucks, and airlines must touch 84% by 2070. Third is the industrial sector. The coal used in industrial sector must peak by 2040 and reduce by 97% between 40 and 2065. The hydrogen share in total industrial energy use, heat and feedstock, that must increase to 15% by 2050 and 19% by 2070. The industrial energy intensity of total GDP must decline by 54% between 15 and 2050, and thereafter by 32% between 50 and 70. Similarly, in the building sector, the intensity of electricity used in the building sector with respect to the total GDP must decline by 45% between 15 and 50, and by another 2.5% between 2050 and 2070. One more important sector is the refinery sector. The crude oil consumption in the economy must peak by 2050 and decrease by 90% between 2050 and 2070. This is the projection and the current status of renewable energy in India. Here it is solar, onshore wind, biopower, offshore wind, solar thermal, and geothermal. And this renewable power is in gigawatt. Now we are here 2022 or 2023. So combining all, we are getting about 150 gigawatts, and by 2030 we will achieve more than 300 gigawatts. So this data is from 2022 to 2023. This is the expected power generation by different renewable energy sources. This is a 2021 Energy Transition Index for the developing Asia, and those are emerging. On the top is Malaysia at 39th position, Thailand, Vietnam, Philippines, China 68, Sri Lanka, Indonesia, and India 87 positions. And here this is a score 52.76. This data is taken from World Economic Forum. Now, if we talk about the Global Energy Transition Index at the global level, for the top 10 countries, the Sweden is on the top, then Norway, Denmark, Switzerland, Australia, Finland, UK, New Zealand, France, and Iceland. And their percentage use 2021 scores. How to enable, how to make or develop the technologies for the energy transitions. The first important area is the electric transportations, where this energy transition is very important. Then use for advanced control and automation, power electronics controllers, energy storage, either at small, local or large centralized, renewable energy integrations, and microgrid ACDC. The power electronics used for the energy transitions is the major breakthrough in future power network related technologies, and it will come from new power electronics technologies. We have to make new controllers for getting this satisfying the energy transition problems. So power electronics controllers and their potential functions, we have to make new power electronics devices, controllers for controlling this one. The energy storage, a high level of research is going on in this area. How to store this energy generated by solar, by wind, by diesel, by some other ways. We are generating the energy and store this energy. And it should provide a demand and balance, supply demand balance. The application of energy storage for grid support includes improve quality of supply, facilitate integration of renewable energy generations, electrical energy time shifting, and use of energy management, and provide ancillary service, that is frequency control, spinning reverse, voltage supports. So what are the challenges regarding this energy storage? It needs low cost, high energy and high power storage. What are the technologies that are existing for storing the energy? The conventional technique is pumped storage, compressed air. In batteries, this energy can be saved: sodium, sulfur, lithium ion, lead acid, nickel metal hydride. Flow battery, fuel cell, superconducting magnetic energy storage, flywheels, and supercapacitors. These are the technologies which we can use for the storage of energy. Here, their relative energy density and power density graph is given. Now, energy storage for grid support. So we should make a large centralized storage, that is for the grid scale, and distributed energy storage, that is for electric vehicles and for the second life of EV batteries. What is second life of EV batteries? Second life of electric vehicle batteries. The electric vehicle batteries have sufficient energy capacity to supply energy for typical house for up to 24 to 70 hours. So the EV battery can be used for the household supplies. And electric vehicle battery is replaced when its energy capacity drops to 80% of capacity when new. After EV use, batteries may be given a second life for large centralized bulk grid storage as size and weight are immaterial. So the use of second life of EV batteries will reduce total cost of EV ownership, and the second life EV battery storage will total 26 gigawatt hour by 2050. What are the challenges in this storing the energy? Cost, reliability, and the lifetime. Development of high energy and high power storage batteries for grid support. Control, that is battery management system, and power conditioning. These are the few challenges regarding the storage of energy system. Then the key challenges for integrating RES. How to integrate renewable energy sources. It's a very big challenge for the researchers, just to synchronize with the grid and storing the energy. First challenge is variability and intermittency of the RES, and these are the inverter based resources. So we have to make a balance between supply and demand. There should be a balance between supply and demand. If electricity demand exceeds the supply, an instant in time, power system frequency will decrease and vice versa. So if demand increases, supply frequency decreases. If demand decreases, supply is more, frequency will increase. What is the mitigation for this challenge? Mitigation is adding energy source storage, improve forecasting, more interconnection with other regions to smooth supply demand profile. That is, make a big grid. Faster dispatch interval, demand response measures, flexibility from other sectors such as transportation and heating and cooling. And similarly, this is the key challenges number 2. These are the high inertia sectors, nuclear power plants, PV and wind system. They are integrating coal power plants and hydropower plants. And the low inertia towards the energy storage system, conventional generator system, gas-based power generation, and PV system and wind system. So these are the few high inertia area and low inertia areas. Lower system inertia, using lower short circuit strength, fault behavior from the inverters, protection issues, spinning reverse use. So this is the grid forming inverters. Keeping in all these in mind, we should make a grid inverter. Now, another possible impacts of large deployment of EVs on the grid. If you are making more and more electrical vehicles, you are deploying the vehicles, so what will possibly impact on the grid? So meeting every requirement, energy requirement of EVs from available grid capacity, a study has shown that UK national power grid is adequate up to 10% market penetration of EVs. So the following need to be appropriately assessed: uncontrolled loading due to increased deployment of EVs, change in voltage profile and violation of statutory limits, phase imbalance, reverse power flow, interference with the network protections. Challenges for the EV owner and manufacturers: high upfront cost and uncertainty about the residual value, limited battery energy power capacity and driving range, charging infrastructures. For example, this is a 3 kilowatt home chargers, and this is a 22 kilowatt street chargers and 50 kilowatt fast chargers. So different capacity chargers of different types are available in the market. And the challenges for the grid are: EVs have high energy capacity and mass deployment, and potential increase in peak demand, charging demand to be met at home, office, and public station. EVs are mobile, active loads and charge controller can be DC or AC, single phase or 3-phase, unidirectional or bidirectional. As range increases, battery size increases, and charging becomes more challenging. Now we can see how this power is generated and feedback. Here, power is generated, then goes to grid, grid to home, home to charging station, to the vehicles. Now, reverse power flow is also possible from electrical vehicle to the station, to the house, to the grid. And here we use high voltage battery. So it is a bidirectional charger. Here it is a profile and its dependence on the feeder type. I'm just using this one. And this is the inputs and output, and analysis is there. Just passing this one because time is less. I have to complete by just 1 p.m. This is how to define any EV loads. Adding EVs to the existing system. Now, active research directions. That is the modeling, randomness, and mobility of EV load. This is one area. Second area is coordinated charging strategies and dynamic pricing. Third is bidirectional capability of EV loads. And fourth is green, efficient, and cyber resilient system. In this area, we can do some very active research. So conclusion is that the energy transition is taking place worldwide, and India is proactively working towards tackling the environmental issues by energy transitions. India is also in race. There are several challenges passed by the energy transition mechanisms, and adoption of green energy and green transportation system are being done worldwide. Science-based framework for achieving net zero, standardized assessment techniques, including digital carbon monitoring system, new high abatement potential technologies for industries and agriculture, and sustainable transportation is an essential component of meeting net zero emission by 2050. So now I just finished my lectures. So now the house is open for the questions. Yes.
Thank you, sir. Any question from the audience side, please? So, thank you, sir. Maybe because this is also Juma time, so
Yes.
I'll not I'll not take more of your time now. So I would request Sayyid Muazzam Ali from the Department of Electrical and Electronics Engineering, Mewat Engineering College, to present vote of thanks to you, sir. Sayyid Muazzam Ali.
Assalamu alaikum and a very good afternoon to all. I, Sayyid Muazzam Ali, Assistant Professor, Department of EEE Engineering, would like to take this opportunity to put my gratitude into words. It's my privilege to propose a vote of thanks on behalf of the organizing committee in third online international conference on recent trends in renewable energy and advancement in engineering and technology held at Mewat Engineering College, No, on 16 and 17 February 2023. It has been jointly organized by Department of EEE, CSE and ECE and is sponsored and supported by Haryana Renewable Energy Department Agency, Government of Haryana. We would like to express our profound thanks to our respected director, Professor Khwaja Muhammad Rafi, for his valuable contribution in this 2 days program. We would like to express our thanks to our keynote speaker, Professor M. Nizamuddin Sahab, Department of Electronic Engineering, for delivering a knowledgeable and inspiring lecture today. We would like to give a very special thanks to our keynote speaker, Dr. Muhammad Rizwan Sahab, Department of Electrical Engineering, AMU Aligarh, for delivering a thought-provoking lecture. My heartfelt thanks to all heads of various departments and the faculty members for their valuable contribution and encouragement in all our efforts to make this conference fruitful. We owe a special thanks to the entire organizing committee members who have worked hard to ensure that his occasion become a memorable success. We would also thanks to all the participants who have attended this conference and presented papers. A very special thanks to our non-teaching and technical staff for their kind support in these events. Once again, I would extend my heartiest thanks to one and all present here. Thanks and have a nice day.
Thank you, Sayyid Muazzam Ali Sahab. Now, because it is already 12:57, so we would be having a break for around 1 hour and 30 minutes. And we will again be here at 2:30. Then we will be having the paper presentation sessions going forward, because yesterday we had covered 3 tracks and today we will cover 2 more tracks. So total 5 tracks have been there in this particular conference, Rtreaet 2023. So I would request all the participants to join in again at 2:30 p.m. for this wonderful conference. Thank you. Your participation is highly appreciated by the organizers of this particular event. Thank you, everyone, for making this conference a big success. Thank you once again.